Hey guys, how's it been going? This is JSer. Let's continue the journey of TypeScript. It's about advanced types, inference from map types. Um, this is nothing special. We have this proxify function, generic, and passing the proxify type, and we have this result. And for each property in this T, the arguments, we have to set the result and get the original value and return the result. So we have this proxy and actually returns the result. The type is nothing special, right? The T. Let's just see the okay here. If we don't have this as, it's still not working. We have this T, and if this original types is room's number, it's still working because we as T here. Conditional types. Yeah, this is like the ternary, the type version of ternary. If T extends to U, then X, or it should be resolved to Y. Why we use extend or not other keyword? Just because these types actually is something about the set theory, I think. There is no such thing as true or false. It's not such big or small. It's just like you belong to me, include or not. So we use extend, I think. Okay. Here is a function. This is generic function. The parameter is x and t. It says the function should be constrained, narrowed to accept boolean, and the return value, it says if the parameter is true, then it should return a string. If not, it should be a number. Okay, let's have a try. So this is the what is it? It's conditional type. Okay. Here. Okay, now you see the type of for x is string or number. If we just pass in the true, you see that x is string. I mean, one string, right? Because it extends true, part of true, so it's string. So TypeScript is kind of clever enough to do that for us. We could chain this ternary up, and because there's no if return in the type, so we could chain the ternary. If it is string, then return string. If it is number, then return number. Then if it's boolean, return boolean. So actually, we could use type name, this generic type, a string, to get the string name, the type name for this type. This is string. Because what? Because type. This is extend string. Yeah. This is string literal, so it's part of the string, so extend matches. Cool. What is this? Would be in the following. Okay, this is full interface. Declare function, generic function, t. If t is full, we return a string. And this function actually has a parameter of x. And we call this function f. If x extends full, then return a string. If not, it should be a number, right? I think there's nothing special here. Let's take a look. That's okay. Hey, for a, it should be a string, and for the it should be a string or number. It's union. We call foo const t equals foo. Let's say props a, prop b. You see, t actually is a we forgot to return a. Yeah, return number. Because t extends full boolean. I'm sorry. It should be true and false. Then t is string. Distributed conditional types. This is simple. For for like a t extends u and xy, if t is a union, then it actually is equivalent to these three, the union types. Okay, so for t, we have this type name, right? We get the name of this type. If we pass a union type like a string and a function, it actually returns us this string and function. Again, string array, or undefined, string undefined object. Pretty cool. Okay, here's another example. Here's a value for t. We box it with this value property, or we put it in an array t array. And boxed, it means if this array, we just put in an array. If not, we put in a value. All right. So we boxed string t1 is string. String is not array, right? So it has boxed value, right? Actually, and if it's just array, we have this array. Or if a string union type of string and numbers, we actually have two box type value and boxed array. It's pretty cool. Now, together with never, we could do something pretty cool, like a diff tu, because t could be the union type. If t extends u, if t parts of u, then never, right? So we get a t. It means we get the parts of t which is not in u. Here is it, diff abcd acf. So we get the bd. Bd is because ac is in u. This is true, so we omit it and only keep the t. So we get bd. Or we could use filter, which means if t is in u, then return t or not or never. So for abcd acf, ac is both in these two types, so return ac. Again, string number function. Obviously we get the string number of omitting the function. If we use filter, then we get the function, right? Also, we have this not nullable. Obviously, we use diff, right, with t, and if they are not null or undefined, we get the not nullable. And not nullable, this one, we have the string number, string omitting the null undefined. Pretty interesting. And here ax, y. So y is the type of x which omitting the null and undefined, right? So we couldn't assign this x to y, because if there's null and undefined, this is not going to work. So now we have two powerful weapons, the mapped types and conditional types. We can map them together. So here is function property names. So this is the interface part. There are four properties, one function, update part, and array, string, number. So we want to say, okay, get me the function property, which is update part. So how should we do it? Obviously, we use maps, right, for each property, and we use the conditional type to check the type, and just omitting the unwanted ones. Okay, so this is function property names here. So for each key in t, if the type value is function, okay, this is non-function. Okay, so here is for each key in t, if that type value is function, so we keep it. If not, we ignore it, right? So this is the, and we get the, what is it? We get the key of t, names. Wait a minute. Okay. Yeah, we get the t, and k, and this is the values actually. So its value is function, then we keep the k. K is actually the property names, right? Ah, I see. So actually this is an object. It's object actually. So we only get the values. T. Okay, wait a minute. Never. So what if we have this? So what is T1? You see that what we get is T1 ID never, name never, subparts never, and this is the function name because we kept the k, right? Okay, so and then we add the key of key. Okay, we're here. T. So what we get now? We get the never will be omitted in the union type. So we get the names. Wow, this is so cool. And if we don't get the not the names but properties, and we could now we just pick the t with these properties, right? And then we say, hey, we have this update part with this. Wow, so cool. Yeah, this is so cool. Interesting. And type inference and inference in conditional types. We have this new keyword called infer, and it will give us the which means we could infer to this type in the latter ones, in the latter expressions. Let's see what it is. So this one actually returns the return type of a function, right? Let's see what happens. Okay, so what it is, we have this function, like a function, okay, const a equals a b string equals true. Let's see. So this is function. What we want is that we want to get the return type of this function. So we call return a type a equals return type of a. Let's see what it is. Wow, it is true. It is Boolean. How did it work? We have these generic type for t because we're getting the function. So the signature, I would say it will be something like this, right? It will be an R. It would be okay. It would be something. We could say any, right? And we want to get this any actually, so we change it to R, and we need to infer it. So this is infer to R, and we'll say the t this function. So if it is could be put against this, I would say this is like the regular expression. Then we get the R. If not, we just return the I would say t itself. No, it's not t. It could be unknown. Yeah, any. Maybe any is better. If it is not function, then return type would be how should I say? It should be undefined. There's no return value for a string, right? Yeah. So yeah, pretty interesting. I mean, what we do is actually we create a template and add the keyword infer. It's similar to the regular expression. Remember, we have this parenthesis to wrap the parts, right? Dot or star like asterisk like this, and then we turn it, replace it with $1 and $2. Remember this one? Yeah, this is just a similar to that, I would say. And rather than the parenthesis, we use this infer, and against it, just like the regular expression match, right? Against it, and then we have the R. So this is the inference. And inference, where is it? Okay. And then, oh, here, I'm sorry. Yeah, here. And we could change this inference up like this, unpack t. T extends infer u if it is array, right? If it's array, we get the original type for each item. And then if it is then function, we get the infer u, so we return the return value. And then if it is a promise, we return the type of the promise, resolve. And then if nothing, we return the t itself. String, 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 array, string, function, string, promise, string, string. Yeah. Pretty cool, huh? Okay. And we actually can have multiple infer. And this is the template. A infer u, B infer u, and we get the u. So for string A, string B, string like this, we return a string or never. And a string or number, we get the union. But here is the very interesting part. The covariant positions is here, right? And here's another example of the contravariant positions. Okay, here is the template. Okay, A, it's a function, and we infer the parameters of this function, and X infer U, the parameters of this function again, and we return the U. By instincts, you might think that we should return the same type as here, right? A string, string, union. While string, union is the string, but actually it's intersection. For a second example, if string number, you will see that is never. So intersection here, union here. They are different because of the covariant positions are for the properties are covariant positions, but the string but the function parameters are contravariant positions. So they get the intersection. So what does it mean by these contravariant and the covariant positions? I will talk about that in the next video. Stay tuned. Okay, with multiple signature, blah blah, last signature. So if there are multiple functions, right? Overload, right? We talked about this before, and if we get a return type of this function, it will get the last one. So this is actually the caveat of the TypeScript. It's not a strong type system. It's just I would say the progressive type enhancement, right? They are not perfect, 100% perfect. Okay, if it is not possible to use infer declarations in constraint clause for regular type parameters, what? Infer declaration in constraint clause for regular type parameters. Okay, type. Okay, t. Here, this parameter. Equal to r. Extends. I mean, yeah. If you use like extends like this, it means the constraint for generic function, and that case we cannot infer because it's the constraint. It's the entry. It's not the exit. However, much the same effect can be obtained by erasing the type variable in the constraint and instead specifying a conditional type. So this is any function, any, and type return type t. This is the array function, and equals t. This is a conditional type. T extends infer, yeah. Predefined conditional types, utility functions. We'll cover it in the next video. Okay, so the most where is it? These three part is the covariant and the contravariant here, right? Let's talk about that next video. Okay. See you next time. Bye bye.